Welcome to being my lab partner. We are doing density lab, and right now I am going to take some data down for you. Remember, you're standing right next to me. Lucky you. Now, I did shower this morning, so don't worry, I don't smell. What I've done now, I'm going to take a 10 milliliter graduate cylinder, put on the balance, and this is a nasty balance actually. You can see how, whoa, it's like, whoa, dude, clean this thing up. But I can't get into my MCC lab. They will not let me in. So I have to use alternate facilities. So this is not my lab, and it would not be my lab because it's too darn dirty. But anyways, I'm babbling. So take down the 10 milliliter graduate cylinder. Mass, you can see that it is 26.511 grams. We're going to try to be as accurate as possible here. I put over on my piece of paper H2O cylinder, the mass of that. This is the empty, of course. I haven't put anything in it yet. 0.511. Okay, that's the graduate cylinder mass. I'm going to take this off and set this aside. And take another 10 milliliter graduate cylinder. We're going to need another one. You might say, well, it's going to be the same, right? It should be the same. No, not necessarily. 26.710, and I'm going to put that down at 26.710 grams for the mineral oil cylinder. Yeah, the second part of the lab, in which, by the way, you should go into Essential Course Document. You'll find the Lab 1 density and get that out, print that, download it. It's going to ask you for an unknown liquid, and well, it's not unknown. I got to tell you what it is, because what's going to happen is you're going to do the percent error for it. So that's the density of an unknown liquid, and that's right there, density of an unknown liquid. All right, so what we're going to do is take this off and place this next to the mineral oil sample so I remember which cylinder it is. And I'm going to get some water. We're going to go grab some water, and I'm going to put it in the first cylinder I balanced. So don't get seasick. I'm a mess, I'm telling you. I just, not getting enough exercise, and just walking over to the sink, it's just absolutely brutal on it. So I'm going to get a little bit of this high quality Made in America H2O. I'll put a little bit in. Now, let's see, pour a little bit out, and we're good. Okay, let's take a look at it. Shut you off. Now, read the meniscus. All right, get down here. And what do we got? Okay, where is it? There it is. There she is. All right, now we're reading this bad Larry here. Getting this in focus. Turn, 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 turn. And you can see that it's around 6 point... Oh, read the bottom of the meniscus. I would say 6.9. 2, 4, 6, 8, 9. 6.9. 6.9 milliliters. So I know you love that when I'm walking around, don't you? 6.9 milliliters for the water. So the volume. Okay, write that down. Volume of H2O equals 6.9. I'm going to say 6.90 because you can read, and well, actually you estimate out to that 100th spot on these graduated cylinders, because I do have the 10 spots on here. Oh, look at that. It's a nice day out, isn't it? And I'm estimating, because you can go 2, 4, 6, 8, and you can estimate, because that's 6.2, 6.4, 6.8, and then you can estimate to that 100th place. All right, trying to be as accurate as possible. Okay, now what? Now we're going to take this cylinder, we're going to plop it back down on here, and we're going to record the new mass, 33.525. 33.525. So I'm going to put here 33.525 grams, and I know this is the before and this is the after, and I have the volume of the water. So at this point, the water part A, is complete. All right, now let's go on to part B, which was the quote, which make makers unknown in quotes, because it's really known. We know what it is, mineral oil. So I'm going to pour some of this mineral oil here in. Let's see if I can do this with one hand. I got skills. Okay. Girls like guys who got skills. Bow hunting skills, nunchuck skills, computer hacking skills, Come on, anyone? Anyone? Yeah, Napoleon Dynamite. One of the most quotable movies of quotable history. Pretty sweet. All right, so we're going to have to read the volume of this bad Larry. Let's see here. I know you're getting seasick out there, aren't you? I think it's fun. All right, get down here. Focus in. And, oh boy, it's hard to see through here. I don't know if you can see that or not. But let's see, that looks like about 9.246. A little under 9.8. So I'm going to go 9.7 and a half, 9.75. My best guesstimate on that last number, 9.75. So volume of oil, 9.75 milliliters. All right, now we're going to put that back on the balance pan and get a reading, 35.197. 35.197. And I'm going to do the same thing here, right, 35.197. So I have my before and my after masses for the oil, my before and my after masses for the water. All right, so that actually takes care of the first two parts of this lab. So let me separate that out. Now, the next part of the lab is take two metals, two unknown metals. Well, it's not necessarily unknown. You're going to have to know what they are if we're going to get a percent error on them. And what I've decided to take, I've got two cylinders here. This is zinc. Got a little Z in on the top. This is lead. It's got a little PB on that. You probably can't see that anyways, but this is lead and this is zinc. So we're going to get the density of lead and zinc. Okay, so let's write zinc, lead. We need the mass of each one. Because remember, density is mass divided by volume, so I'm going to get the mass. So the mass of the zinc, okay, we've got this teared out. Put this on here. The mass of the zinc is 70.253. 70.253 grams. All right, so with that one, let's get the mass of the lead. Mass of the lead, 67.863. 67.86. Oh, I just went to 2. It does that air currents. I didn't close this thing because they were out to the 1,000th place at this point. It's not going to matter. So you can see that the balances are quite accurate. They go out to the 1,000th place. Actually, the analytical balances we have in the Chem Lab at MCC is they go out to the 10,000th place. So they're quite accurate. So those are the masses. What I need is the volumes of these two items. So what I'm going to do is I'm going to take the larger graduated cylinder. Okay, this is the 100 milliliter graduated cylinder. I'm going to put some water in it at a level. It doesn't make any difference what the starting level is. I'm going to put some water in it. And then I'm going to carefully drop this in. I'm going to angle it and carefully slide the metal in. Zinc first, and then I'll be able to get a volume change, a displacement, water displacement when I have the water rise. And Archimedes, Eureka! No, I don't. As I said earlier, I have showered, so no, I don't smell. No. Eureka! That's what Archimedes said when he discovered the water displacement as a way to get the volume of a solid object. All right, especially if they're irregular shaped. You can't just length, width, and height, everything. Actually, we could get the volume of these if we wanted to by using the volume of a cylinder, volume of a cylinder. We could do that. We could measure the radius and length. But now we're not going to do that. We're going to do water displacement. So I'm going to put this in water, put some water in, record the level. Put it in afterwards, record the level. See the water displacement and get the volume of each one. So we're going to record that as the volume of the water. Now, what I'm going to write for the volume of the water for each one is over here, volume before, volume after. That means before and after I put the metal in. And I'll do the same thing down here for the lead, volume before and volume after. And this here, the volume of the water displacement, is going to be actually equal to the volume of the metal, which in this case here it's lead. So this is going to be, when I subtract these two, so volume before minus volume after, I can get some value for it. I'll put it here. The volume of the water displaced is equal to the volume of the lead. And same thing here, volume of the zinc before I put the metal in, or volume of the water before I put the metal in, and then after I put the metal and the zinc in, we'll get a volume water displacement, how much water was displaced, and that is going to be equal to the volume of the zinc. All right, so we gotta get those measurements. So what I'm gonna do at this point is shut the video off because you're getting seasick, and I have got to be able to hold this. I can't just drop this piece of stuff in here. It's gonna break the graduated cylinder, so I've gotta use two hands. All right, BRB.